All right, in our first video, we are going to rewrite an exponential function to identify a rate. So our first example, in 2015, the population of a small town was 8,000. The population is increasing at a rate of 2.5% per year. Rewrite an exponential growth function to find the monthly growth rate. Okay, so first, we're going to do this. We're going to write an exponential growth function, and then we will rewrite that in order to find the monthly growth rate. So an exponential growth function, we saw in our last lesson, has the form y equals a times, because it's a growth, we're going to say 1 plus r raised to the t power. A is our initial, population. So we're going to plug in an 8,000 for the A. That should be a parenthesis. 1 plus r is the growth rate as a decimal, so that's 2.5%, but we're going to turn that into a decimal and have 0.025. And then t is our number of years, which we don't know, so we're going to leave that as t. We can simplify this. Why don't we just identify a couple of things that we just said and we just make sure we have in our notes. So that 8,000 is the initial population. The 0.025 is the annual growth rate. And then the t is the number of years since 2015. Okay, we'll just go ahead and simplify that. The simplifying we can do is just add together. So we have y equals 8,000 times 1.025 raised to the power of t. All right, so that's the first thing we needed to do, but they asked us for the monthly growth rate. Right now, our rate of growth is in terms of years. Our time is years. So how do we manipulate this so that we can look at this in terms of a monthly growth rate? So what we're going to think about is the fact that there are 12 months in every year. So how many months are there in t years? You know, if it's 2 years, that's 24 months. If it's 3 years, that's 36 months. So if we don't know how many months and we're using, we're just trying to set up a formula we can use for any number of years, the number of months is going to be 12 times our number of years. 4 years has 48 months. Okay, so what we're going to do is we're going to take our exponent. Let me just go ahead and rewrite. Y equals 8,000 times 1.025. We're going to take our time and multiply it by 12 over 12. So technically, mathematically, we're multiplying it by a 1. So it doesn't change the value of anything, but we are able to manipulate this so we can narrow it down to a monthly growth rate. So let me show you how we're going to do that. This 8,000 is going to stay the same. And then we have 1.025. Well, t times 12 over 12 is 12t over 12. Now, it's very tempting to just cancel those 12s out, but we wanted a 12 over 12, so we know that we're really just multiplying a 1. So what we can do now is with our exponent properties, we can separate out 0.125. We're going to take this 12t over 12, and we're going to separate out a 1/12 times 12t. So if you remember your exponent properties, I can raise the 1.025 times a 1/12, and then that's going to be raised to the 12t power. And isn't 1/12 times 12t the same thing as this 12t over 12? Which is the same thing as our t times basically a 1. So what that does is it changes my exponent to 12t. That's what we wanted. But that does mean that our growth rate is going to change. So what is the growth rate now that we turned our formula into a monthly formula? All we have to do is figure out what 1.025 raised to the 12th power is. So y equals 8,000 times, when you raise that to the 1/12th power, you're going to get 1.00206 to the 12t power. And again, now that we have an exponent of 12t, we're working in months. And then this right here, the 1.00206 will help us get our monthly growth rate. Oh, could I have written that any worse? Sorry about that. So if we just, because remember, it came, our growth rate comes from 1 plus whatever that growth rate is. So let's take our 1.00206, let's subtract out a 1, and we're going to have a 0.00206 as our monthly growth rate. Let's turn it into a percent. Just move that decimal over 2 times. So we have a 0.206%, which is about a 0.2%. So it's very, very small. It's less than 1%. And then we can just summarize and say the population is increasing. About 0.206%. Now we're no longer in years, so we can say per month.